Hey everyone. Yeah, I'm here to talk about the L2 EVM Common Core. And it's basically this initiative, that's a recent initiative that came out of the RollCall process. And so if you've never heard of the RollCall process, that's something we started earlier in the year, and it's basically a L2 coordination effort. We have a monthly call where many of the major L2s on Ethereum send representatives, and it's basically for now mostly used as like both coordination across them, also a bit of a trying to be a bit of a connective tissue to the L1. I'm personally spending most of my time in L1 core development. And then we also have what we call RIPs, Rollup Improvement Proposals, and the idea there is basically that they are similar to EIPs. EIPs, you might be familiar, that they are proposals to add new features to the EVM on L1, and so that the RIPs are the equivalent for the L2 side of things. And yeah, the process was originally kind of started, the roll call, by Carl, who can't be here today, unfortunately, Yoav, and me, and then more recently Nico also started joining us more actively. And yeah, I want to basically talk a little bit about EVM equivalence in general, and then kind of the specific kind of direction that we see the EVM equivalence go in the future. And I wanted to start a little bit with history. It's going to be a bit more of like an easy kind of beginner-friendly talk, at least in the beginning. I like pictures, so I have some pictures. In principle, the way I always think about scalability for blockchains is basically as this fundamental trade-off between the cost to run a full node and the throughput you get, right? And so Bitcoin, Ethereum, two early examples. Ethereum has more throughput than Bitcoin, but it's also a bit harder to run an Ethereum full node than it is to run a Bitcoin full node, right? And I call these kind of trustless chains because the important thing is everyone on Earth who wants to can verify the chain. At least that is the goal, and we are sticking at least pretty close to that. And then there is the kind of the approach of just going further up the diagonal and just picking Solana as an example here of chains that basically just say, okay, we want higher throughput, and how do we get there? Well, we basically go up and we accept that now it is harder to run a full node, but we get more throughput. And of course, the trade-off is that now you actually need to have a quite beefy machine to be able to still trustlessly participate. Otherwise, you have to trust the majority of nodes. Now, ideally, we want to go there, right? The ideal chains, like they have very low cost to run full node. Everyone can verify, but they have high throughput. So how do we do this? We basically, this is the key roll-up trick, right? We realize that actually what matters is the cost to verify the chain. And if there's a way to verify the chain cheaper than running a full node, that's sufficient. And that's basically how we get to rollups, because rollups are basically a way to compress verification of a chain. And so what you can do now is, once you get to that place, you can do either, you know, basically the thing you could immediately think of is just, hey, take the high performance chain and just run it as a rollup. And there are some projects now on Ethereum that do this, that are Solana VM based. It's a bit of a challenge though to adapt them for L2s. Then of course what you can do is as well, you can just take the EVM and you can really scale it to high throughput. People sometimes have this mistaken conception that like the EVM is fundamentally not able to go to similar throughput levels as the SVM. That's really not the case. The reason why Ethereum runs on lower throughput is specifically because we want this trade-off. We want to be verifiable by everyone on Earth in a trustless way, right? It's a choice. It's not a technical constraint. So once you go into the rollup, you can actually push the EVM to its limits. But the variant of this that we've seen the most is actually what I call, I don't know, the multi-rollup cluster, which is just like many smaller, like lower throughput individual rollups that basically together form like a very high throughput system. So that's kind of like the background of how the ecosystem evolved, like as Ethereum went basically through its rollup-centric roadmap. And if you zoom into like now the chain itself and then eventually the EVM, I have some more pictures. I call basically this just like the execution chain. It's just a symbol that's representing chains where actual activity happens, right? Like chains that actually offer execution, where you can build apps on top. And the most basic version of a chain is just like a self-contained chain. It's like an L1 with just normal dApps on top. But now you want to turn it into a rollup. How do you turn it into a rollup? Well, you need settlement and data availability. And those two things can be provided in a combined way by a settlement chains. So then, once you have a settlement chain, you can just take your chain there and just turn it into a rollup. And the nice thing there is that now you inherit the security of the settlement chain, but you can still now yourself run with much higher throughput, right? But because you have that security that you inherit from that low throughput but high security chain. That's kind of like how this best of both worlds solution works. And that's kind of how you get to this world, right, where you have a settlement chain and you have a bunch of rollups on top. Now, this was basically the original vision for what people back then called ETH2. You might remember before the merge, people used to call kind of like the beacon chain ETH2. And we moved away from that name, and that has a specific reason. Why? Because ETH2 was this vision that we would basically give this new chain some fancy new execution and settlement system, and we would take the old ETH1 chain and the old EVM on top, and we would retire it. Back in the day, there were a bunch of different thought experiments. You could turn it basically into some sort of rollup on top of the new ETH2 chain. You could just have it parked somewhere on the side with some, either like proof of work forever with some bridges to the new system, or just even over time deprecated or something. But then at some point, basically, as we moved closer to the merge and to these ideas, people realized that, hey, actually the ETH1 chain is kind of good enough for what we need for the settlement chain. And so that's why then instead the plan became, let's merge the existing system into this new ETH2 chain, and that's why we kind of stopped calling it ETH1 and ETH2 and instead just call it Ethereum again. And so that's why today what we have on Ethereum is this hybrid settlement and execution chain, right? So like down there, that's what Ethereum is supposed to be like. That's both the settlement thing, settlement and data availability, but we also still have execution. You can, have your UA on L1, you can use Uniswap on L1, all of that still works on L1. And it's all still powered by the original EVM that we used to have on Ethereum from the early days. Right. So that's basically like how the role of the EVM evolved, and how for a long time the EVM was basically supposed to have like an expiry date, and then it turns out it actually didn't. Now, how do L2s and their execution systems fit into this? Well, actually, when we first pivoted from sharding to rollups, the idea was, well, this is going to be amazing because now all the L2s can go on this wild exploration and see what type of new fancy execution system works best for them. But then it turns out we have seen a little bit of that, and I said that earlier. We now see experimentation with the SVM and MoveVM and like more fancy high throughput EVMs and whatnot. That happens a little bit, but the vast majority of L2s actually basically followed the network effects, and they were like, well, there's already a lot of dApp developers for the existing EVM today, so what we're going to do is we're going to just copy the EVM, right? We're going to copy the EVM, and we're specifically not going to make changes to it, because otherwise apps would not be compatible. It doesn't mean that the L2s were not innovative. I would say quite the opposite. I think we've seen like 3-4 years of pretty rapid innovation in this space, but that was very much focused on the specific new challenges for L2s. So that was focused on like new functionality and like fault proofs, ZK proofs. Of course, in the ZK space, the innovation has been amazing to see. And then when it touched the EVM, it was more like extension. So I'm not sure how many of you are familiar with Arbitrum Stylus. That's an example of an extension to the EVM that left the core of the EVM unchanged and just added something on top. And then one more wrinkle to this, the consequence of the EVM equivalence was also that most L2s ended up just going with the dominant L1 EVM client, which at the time was Geth. Of course, Geth is still the most popular one. By now, there are also others that are a bit more on equal footing, but back in the day, really, Geth was the only main one, and so it, for that reason, is still the very dominant client in the L2 space. So that brings us to the present, and this also brings us to the point where like the pictures part of the presentation ended, but because I got so much feedback in the past that my presentations don't have enough pictures, I decided to just add one extra picture to every slide from now on, so you'll get a few bonus pictures, starting with this cat. But let's focus mostly on the content. So today, where are we at? We have the EVM on L1, and it basically, if you look at the kind of new features that we've shipped on the L1, we have roughly one hard fork a year. You will see that we don't really ship new features to the EVM that often, right? Like it's a pretty low frequency. We've had a few more what I would call ambitious features in the past. And by the way, this is a good point to briefly mention. I say EVM a whole lot throughout this talk. What I mean is technically not just the EVM, like the core EVM itself, but like the execution system as a whole, which is a little bit more expansive. Some people are always like, oh, but state expiry is not technically part of the EVM. Yeah, so basically when I say EVM, think execution in general. But we've had basically a few of these more ambitious features that we worked on and actually basically got all the way down to specs and the ability to, in principle, ship them, and then rejected them. So that was two of them that I worked on in the past were state expiry to manage the state size on Ethereum and native account abstraction. And both of those were ready like 3-4 years ago, and we just decided, hey, it's just not a priority for L1. And then even when we ship new features to the L1, which we still do, admittedly, and like some of them are actually quite exciting, we still very much focus on what the L1 needs, right? And so that's specifically, for example, ERP 7702, which I'm quite excited about as one of the co-authors, which is giving some smart account functionality to existing user accounts. That is EOF, which is upcoming, which also I think is actually a little bit underhyped. I mean, I guess you have probably heard the term, but I think it's going to be quite amazing. And then a little bit further down the road, something like Vertical trees. It's not 100% decided if it's quite going to be Vertical trees or some variant of it, but basically that is in the pipeline, but it will take several years to arrive. And it's very much something that primarily is interesting and nice for the L1. So where does that leave the L2? Well, it turns out that most of the L2s that started out as equivalent to L1 basically now are stuck in that position, right? The point is that you don't want to be the only chain that starts deviating, starts implementing features that no one else has, because then none of the wallets, none of the tooling, none of the dev tools are compatible with you, right? And so what that means is like now these L2s in a way are stuck with the EVM of L1 and are stuck with the kind of the slow speed of these new features that are being shipped. And in particular, it's not just clearly the L1 is very conservative, ships features in general, not quite as fast as L2s, but it's also a fundamental difference in constraints and priorities. So it's about throughput ambitions, the difference in full node requirements. That comes back hopefully to the graph, right? If you remember how basically the rollups give us this best of both worlds. You can run these very demanding, very high throughput chains and still inherit the security of the L1. Well, but that also means that you're building a system for very different requirements. Block building works very different on L1 versus L2. And then, of course, for the ZK rollups, ZK basically changes everything in terms of how expensive different operations are and how the VM should ideally work. So basically, all of this means that like the EVM is just not an ideal fit for what the L2s need. Also, Geth is still the main client on the L2 side, but Geth is very much focused on the L1. Like the team very much has made it clear over the last few years that while they are, they're very happy that they get so much adoption on the L2, that they have very limited bandwidth to basically try to provide L2 specific features. But that's the silver lining here. We have seen several L2s, several other clients gain more adoption in the L2 space that are more willing and more focused on that use case natively. So where do we go from here? How can we basically make sure that we give L2s the best way to really make the most of this kind of this best of both worlds trade-off space there, where they are in this unicorn range of basically high throughput with low trust requirements? Like how can they basically have an optimal system designed around this? Well, two pillars basically, that we have been focusing on. First one is just make sure that all L2s have a client that actually is willing to focus and support the L2 use case more natively. And so that specifically tried to identify and try to eliminate this bottleneck of the L1 focused Geth team, not eliminating the Geth team, just eliminating that bottleneck. And out of that came the collaboration with Nethermind, which is what we call the Rollup Geth team, or what they call the Rollup Geth team, which is a fork of Geth. It starts out identical, but over time we'll add more and more L2 native and L2 specific features, and we'll basically join the set of L2 focused clients, right? Like Nethermind also, they have their own clients, so Nethermind now has the Nethermind client and the Rollup Geth client, both of them happy to support L2s. Then there's also Reth, there's Besu, there's Aragon. So we have now is basically an entire team of clients that are willing to basically support L2s. And basically, ideally, that way we can basically leverage the existing kind of skill set that we already had in the Nethermind team and really kind of help L2s there. So that's pillar one. Pillar one is make sure that all L2s have a client that is willing to support rollup specific features. Now, as I was saying, that is basically joining the kind of the broader set of clients, and now we can basically start to ship more IPs, more ambitious IPs, because the clients can support them. The problem is that on its own, that's why it's only one of two pillars, because that on its own does not get rid of this kind of fundamental lock-in of the EVM equivalence, the equivalence to the L1 constraints. And so that's where the second idea comes in. That admittedly is a bit more opinionated. This one might or might not play out. That's something that we've proposed to Rollups just over the last month or so. And there's a lot of interest in this idea, but it's not clear that that will actually play out. So that's basically the proposal that I wanted to talk about here today. The idea is, we call it the L2 EVM Common Core. And so the idea here is to just say, hey, basically, let's just start, like what you really want as L2s is you want to be equivalent to each other, right? Because that is where the network effect is. And you don't really care so much that what you are equivalent to is exactly the L1. So what we want to do is we want to take the L1 EVM and over time extend it more and more and have that be the shared target that everyone focuses and everyone supports. And that way, tooling, Solidity, all wallets, all these kind of, the full stack can now start supporting this L2 Common Core as the base feature set, and we can really start shipping more ambitious features over there. And yeah, just to illustrate, I count that as an image. That's basically like how you can think of the feature set of a rollup, right? So you have the L1 EVM as the core. Everyone supports all the features of the L1 EVM. In the future, there would be this extra ring, which is the L2 EVM Common Core that also everyone on the rollup side would support. Then, of course, you have stack-specific features. So if you are on one of the OP stack chains, then that would be OP stack features. If you're on Polygon, that's the Polygon features, etc. And then every chain also has some features that make it unique, right? And so that's kind of the outermost ring. And so what kind of features are we talking here? Like, what could we bring? Well, basically, the idea is really just let's open the design space again, right? Now that we have a platform to basically ship more ambitious features, let's just look into what we have there. So in the short term, that could just be things like basic repricing that to make it, for example, more ZK native. A 2D transaction type, that's something that I think would be really nice. Right now, the way L2s charge users for the settlement cost differs from L2 to L2, which doesn't make for great UX. I've sent a transaction on Optimism once, and my wallet said, at most it's going to be 1 cent. I sent the transaction, and it's 10 cents. And I mean, yeah, it's still only 10 cents, but imagine if that would be factor 100, you know, like all of a sudden it would be not so funny that basically that doesn't work. So having a native transaction type for L2s would actually be quite fun. Delayed state root computation is maybe a bit nerdy. It's a feature that people have been talking about a little bit that could basically make block processing more streamlined. And then in the long term, that's what I'm really excited about, these kind of features. So that would be things like native account abstraction. I'm not sure how many of you all have a smart account, have heard of ERC 4337 in the past. There are proposals to basically have that be natively embedded into the protocol. Eventually, I think this will also come to L1, but it will take years and years. we can ship it in the meantime on L2. Transaction parallelization, state expiry, statelessness, state rent, like basically figure out a way for how we can basically manage state and state growth more aggressively. And then something I personally am very excited about because I've been working on that in the past is multidimensional pricing. I think we're basically out of time. Let me see, I think I only have like 2 quick slides, so let me just rush through them. Next steps, again, the Common Core is a bit more unclear yet, like that's a proposal. We will have to see how much interest is there really and how much willingness to commit to this across the L2s. Figure out a governance, because given that that would be a shared set of features that everyone would commit to supporting, that requires governance among the participants. And then have a research process across the teams. And that also would mean that for RollCall, in the season 2 of RollCall, we would basically focus also on facilitating that side of things more. So that's all. I hope that gave you some intuition around why that is at least an interesting direction and why there is some use in trying to eliminate this bottleneck of the equivalence to the L1, which really has very different constraints from the L2s. Thank you.
Okay, cool. Let's scurry towards the middle because we have some questions that need to be answered. So starting from the top, can you quickly explain why EOF is underrated?
Yeah, that might be a question from an EOF hater. I can already feel that, which is fine. You know, I think EOF is one of those features where not everyone loves it. I personally am the most excited about it specifically in the L2 context, actually, and I guess that goes a little bit counter to the slide that said it's a L1 specific feature, but because the nice thing is it gives you version bytecode. So far on Ethereum, we only have one type of contract code, so if you deploy something, it will always behave the same way no matter what. With EOF, contracts can now have a specific version, which means you can basically have different behavior depending on a version. And so that means you can have like backwards incompatible breaking changes, new types of new features. We have Dano in the audience. Dano is like the expert on EOF. So if anyone has like actual good faith questions about EOF, go talk to him afterwards. He's like the Bible on EOF. But I'm a fan.
Okay, what is the best alt VM from your view?
Ooh, spicy. I mean, I don't really have an opinion. I think I'm very, very excited that we now have this Cambrian explosion of L2s. I know that some people on Twitter are like, oh, you know, yet another L2, yet another L2. I actually think there will be, like, we'll look back at this time and we'll be like, oh, we only had 100 L2s. You know, now we have 10,000. So I think we'll get a lot more L2s before we get fewer. And I think that's a good thing. I have no idea. Some of them will work really well. Most won't. And then we'll see which winners emerge. I mean, of course, I do think, of course, one interesting direction is SVM-based ones, just because, you know, Solana is a very interesting kind of alternative network. I think as an L1, it doesn't make so much sense. I want to actually be able to verify that someone is not stealing my money. But as an L2 software stack, I think it's an interesting direction to explore.
Do L2s also, oh, it's changing, upvotes are happening. But I'll start, I guess, 2 votes win. Will L2s remain able to execute contracts written for L1, or will compatibility be lost?
Yeah, that's great, because that question shows me that the person actually was thinking during the presentation about like the edge case, like the implications of this idea. Like that's actually exactly like a really interesting question. Like, will we be able, like, how close will L1 and L2 Common Core, if it starts to diverge, how close will they remain? I would predict that for the next foreseeable while, probably you can write the same code for L1 and L2. I think at some point we might reach the point where L2 might want to ship features that unlock new capabilities like parallelization, like asynchronous communication within the same block or something that might just make it impossible to keep the compatibility, but we will see if it's worth to break. My prediction would be long-term L1 and L2 will probably diverge to the point where you have to write L1 specific code if you want to deploy on L1.
Interesting. Do L2s also, oh my God, things keep changing. Will Nethermind make Rollup Nethermind?
Well, the fun thing is that Rollup Nethermind is just Nethermind. Like the Nethermind client is very willing to actually focus on shipping features that are useful for L2 specifically. So the only client that needed a Rollup upgrade was Geth specifically.
Okay, we'll finally get to this one. Do L2s also aim to have client diversity?
Yes, great question. And that is also, even though, say, for example, more and more rollups are starting to adopt Geth and Nethermind and these other clients, and you could just say, well, why even bother with rollup Geth? Because you could just wait until they all switch over to one of those clients that is more natively aimed at the challenges and the kind of the features that the L2s want. But the answer is, actually, it's very, very valuable, even if they start supporting these other clients, to keep Geth compatibility so that you can go to this multi-client world. Because, say, for example, I mean, already for fault proof, it's very nice. But then also with ZK proofs, it's very nice if you have multiple kind of independent paths that you can prove something from. So then you can have like a 2 out of 3 ZK kind of disagreement rule or something. All of that is unlocked by multi-client. And I think L2s are on a path towards multi-client.
Okay, perfect. That